Hey guys, welcome back to another video. So in this video, we're going to be looking at logarithms and logarithmic functions. And the first thing to know about logarithms is that you can rewrite them in exponential form. So you can rewrite them as an exponent. And I'm going to show you how to do that here today. So with any of these problems right here, these examples, the little number right beside the log is going to be your base. The exponent is always going to be what the logarithm is equal to. So in this case, 4 will be our exponent. And then 2 to the 4th equals whatever that number is right there. So 2 to the 4th is 16. So this is how you can rewrite a logarithm, guys, as an exponent. So we could do this one as well. That would be the base is e. The power, or the exponent, is 0. And anything to the 0th power, we know, equals 1. So that's kind of the main idea when it comes to rewriting logarithms as exponents. Now, we can kind of go back the other direction, and we can rewrite things that are in exponential form in logarithmic form. So for this first one here, we know that so we'll go ahead and put log in. We know that our base 5 is what we put in this little bottom right corner of log. The exponent is what it's equal to. So we have 2. And then 25 goes right here. So log 5 of 25 equals 2. Let's do one more. Let's do part D here as well. So we could do log. This is going to be base 6. The 6 is the base of log base 6 of 1 over 216 equals the exponent, -3. So really you're just going back and forth between exponential form and logarithmic form. So logarithms are just another way of writing exponents. All right, when it comes to evaluating logarithms, sometimes if we write them in exponential form, then it's easy to figure out what we're doing. So we know that the base is 4. We don't know what the exponent is because we don't have an equals yet. We're trying to figure out what that is. So 4 to the x, we'll just put an x for that. 4 to the x we know is 64. So 4 to what power? We're asking ourselves that. 4 to what power gives us 64? And so we can try it out. 4 times 4 is 16. 16 times 4 is 64. So we know our x has to be 3 in this case. Another way we can do this is using our calculators. So we'll go ahead and do part B on our calculator. I have a TI-84 Plus here. And what you can do on your calculator is if you go in and press math, and then go down until you see part A, which says log base. Press enter on that function, and it'll give you this, which you can then fill in with the parts. So we want a 5 for the base and a 0.2. It'll go inside there. So then when we press enter, you can see that we get an answer of -1. So -1 is our answer to part B. So you can use a calculator, or you don't always have to have a calculator. All right. Also, on our calculator, we have 2 buttons, which I'm going to show you here. One button says log, and the other one says ln. That's natural log. Both of those are special logarithms. When you see the log button, log is just going to give you a base 10. So it's going to be a logarithm with a base 10. And the natural log, ln, is going to give you a logarithm with a base of e. So we can use that on our calculator to evaluate these. So we can just press in on our calculator log 8. So I'm going to do log and 8. So we have log 8 here. Press enter, and we get 0.90. It says to it says to 3 decimal places, so we'll do 0.903 for log of 8. And then we want to do natural log of 0.3. So we'll do ln of 0.3. So it'll look like that, ln of 0.3. Press enter, and we'll get negative 1.20. Negative 1.20. And that's the ln natural log of 0.3. So we can use our calculators for that. All right, let's look at inverse properties. And I'm going to write these down for y'all. We have 2 inverse properties. So if we have the log base b, we're just going to put a b in that place. Log base b of b to the x power, where these 2 numbers are the same, then the answer is just going to be whatever x is. And another one of the inverse properties says b, if we have b to the log, log bx, like that, where these 2 numbers are the same, then again the answer is just whatever x is. Okay, so if we look at this first one, part A here, the log, notice it doesn't have a base. Anytime it doesn't have a base, it's going to be a base 10. So we'll have 10. This is this example right here. So we have 10 as the b, and then the base of log is also 10. So since those are both the same, then the answer is just going to be whatever we have the log of. So the answer to part A is just going to be 4. Right? 4. It's just that number there. Now, for part B, notice that B and B need to be the same. 5 and 25 are not the same. So we can rewrite, let's do this. Let's rewrite log base 5, 25x as log 5 of 5 squared. Isn't 5 squared the same as 25? 5 squared to the x. So we're just rewriting 25 as 5 squared. And then would y'all agree that when we raise a power to a power, it's just 2 times x? So we would have log base 5 of, we can just rewrite this, oops, log 5 of 5 to the 2x power, right? 2 times x, 2x. Now, since both of these are the same, according to this inverse property, since both these are the same, the answer is just 2x. 2x. So there we go. So we can use these inverse properties, these 2 right here. We can use these 2 inverse properties to solve and simplify some problems. All right. Now, finding the inverse of functions. This is the same thing we've done before. We'll replace the f of x with an x and replace the x with a y. So the opposite, in this case, by the definition of a logarithm, we can say that the inverse is just going to be log, so y equals, the inverse is just making sure that I tell you this right. It's just log base 6 of x. Okay. So these are comparable, right? All right. And then to solve for, and this is from our definition of a logarithm. For this one over here, again, we'll replace the f of x with an x. Then we'll have ln of y plus 3. To get rid of that natural log, we will do the opposite, which means that we could do e to the x power over on the right, on the left side, to get rid of that natural log, and then we'll just have y plus 3. And then we can just subtract 3, so we'll have y equals e to the x minus 3. And there's our inverse function right there. Okay. Finally, graphing logarithmic functions. You can do this using Desmos or any graphing calculator. And we can see what our domain and range would be. All right, so I'll leave that to you. You can read through this, kind of make sense of it. And remember to figure this out, or to graph it, you can put it into Desmos or any graphing calculator. Okay, let me know, guys, if you have any questions about logarithms or logarithmic functions. Anyway, guys, thanks for watching, and I'll see you in the next video.